Hello viewers, my name is Dipti Mukherjee and today's topic is Euclid's definitions, axioms and postulates. Euclid was an ancient mathematician and he wrote a book that is Elements and he wrote some definitions, some axiom and postulate. Definition for geometry and axioms are some statements which are true for not only for geometry but also for other parts of mathematics, that is a whole part of mathematics. And then he also gives some mathematical statement that are postulate which are only for geometry. So the axiom and postulate, the main difference is axiom is used for whole mathematics and postulate only for geometry. Now definitions. These are a very ancient times book element and the definitions are very simple and we all know these definitions because it was very ancient time. It was a very early time and so he wrote some points and now modern geometry is the modern root of that definitions and we know all things, and after reading this or after watching these points you can realize that these are so simple and we all know these things. So first 7 definitions, then 7 axioms and then 5 postulates, and I will discuss every point. First 7 definitions. First definition. A point is that which has no part. That means no dimension. We just locate any point and which has no part. This is the first definition for point. And we know that a point has no length, no breadth or no height. That is point. This is the first definition. Now second, a line is breadthless length. That means a line has only length, no breadth. That is the definition. And when we draw a line, we can understand that only length, no breadth. That is line. Now third definition. There are 7 definitions. Third definition. The ends of a line are points. This is the third point. And when we draw a line, we can see that the end are the points. The end of the line are points. This is the third definition. Now fourth definition. A straight line is a line which lies evenly with the point on itself. That means a straight line is consist of many points, and all points are in that statement, that straight line. And this is the meaning of this definition. And we know this is so simple, and all definitions are so simple that we can think that these all are known definitions. So, next definition. Now, fifth definition: a surface is that which has length and breadth only. Now, sixth definition: the edge of a surface are line. When we see any surface that is length and breadth like a rectangle or any type of surface, then we can see the cube or any type of rectangle, and then the edge of that surface are line. This is the definition, and we all know this also. Now, seventh definition. A plane surface is a surface which lies evenly with the straight lines on itself. This is also, we know that it is also known by us. In another word, we can say that when we draw many lines, and these lines, combination of these lines make a surface. So that is also true. Now, axioms. There are 7 axioms. And now I am just explaining the axioms also. Axioms, first axioms. Things which are equal to the same thing are equal to one another. Like A equal to C, B equal to C, both are equal to C, so A equal to B. This is the explanation of this axiom. That means same thing, things which are equal to the same thing are equal to one another. That means A equal to C, B equal to C, then A equal to B. Now, second axiom. If equals are added to equal, the wholes are equal. Let A is equal to B, so A plus something like A plus X, and we add the same thing to B, that is B plus X, then A plus X is equal to B plus X. A equal to B, so A plus X is equal to B plus X. That is true. Now, third axiom. If equals are subtracted from equals, then remainder are same. Like equals, A equal to B, then A minus X is equal to B minus X. Now, next axiom. Things which coincide to one another are equal to one another. Coincide, what is coincide? Coincide means overlap, or we draw a straight line and we draw another straight line, overlap of that straight line, then both straight lines are equal length. That is the meaning of this axiom. That means if we draw any circle and then draw another circle overlap of that circle, then both circles are same, equal. That is the point of this axiom. Now next axiom. The whole is the greater than the part. Like we take a whole part, like a bread, total bread or egg roll, and we divide it in two parts, then two parts are less than the whole part. A total egg roll and divided in two parts, then two parts are each part are less than that total part of the or whole part of that egg roll. That is the example. So always it is obviously that whole part is greater than the part of that things. Now next axiom. Things which are double of the same thing are equal to one another. Like A equal to B, and we double 2A, A equal to B, 2A, and double B, 2B, so 2A is equal to 2B. So now next axiom. Things which are halves of the same things are equal to one another. This is also obviously we can explain it, because let A equal to B, so half A is equal to half B. So if we multiply with half of any two equal things, then after that half or after that multiplication of half, the remaining part is also same. That means half A is equal to half B. Now postulates. Postulate number 1. A straight line may be drawn from any point to any other point, and we know that we can draw from any point to any other point a straight line. That is the first postulate. In postulate 1, we can explain that we can draw only one line within 2 points, and we can draw many lines in one point, but if we join 2 points, then we can draw only one line. Now postulate 2. A terminated line can be produced indefinitely. That means a terminated line, that means a line segment. When we draw a line, a part of line, and we want to produce this line, we can draw indefinitely. There is no end of that point, we can draw indefinitely. This is the next axiom. Next postulate. And I have already discussed about postulate and axioms. Here point and straight line, these are all related to geometry, and axioms are related to whole mathematics, not only geometry. We can't use this postulate or in algebra or any other part of mathematics. So these are postulates. Here I have discussed that a terminated line Now we can say that this is a line segment, and in terminated line we can produce indefinitely. That means no end of that line we can produce indefinitely. This is the second postulate. Now third postulate. A circle can be drawn with any center and with any radius. We can draw anywhere, here, anywhere, any center, any point, any radius we can draw. That is the next. We can draw here, anywhere. That is the postulate. Now next. All right angles are equal to one another. Obviously all right angles are 90 degree, and we can draw here in this way, and here in this way. We can draw upward, downward, sideway, any type of right angle. Then obviously all are same, because the value of right angle is 90 degree. So we can draw it sideway or vertical or horizontal or any way, upward or downward, all are same. Now next, postulate 5. This is very important postulate, and please watch it carefully, and I will explain it because this is very important postulate, and we can also derive many statements, theorems from this postulate. So please watch carefully this postulate. If a straight line falling on two straight line, one straight line falling on it, and these straight line are not parallel. This may be curved or any type of straight line, and two straight line and one straight line falling on the straight line makes the interior angle of the same side. That means two straight line and one straight line cut this two straight line, then interior angle of the same side of it taken together is less than two right angles. That means two right angles means 180, 90 plus 90. Less than 180, if the interior angles are less than 180, then the two straight lines, if produced indefinitely, meet on that side on which the sum of angles is less than two right angles. That means when we draw two straight line, here I am explaining, draw two straight line, and these are not parallel, and we draw another line which cut this two straight line, and if interior angles are less than 180, then and we if produce it indefinitely, infinitely, then it will cut one another at any point. If the interior sum of interior angles are less than 180, and if it is greater than 180, then it will not meet any time. It is not possible to meet each other. But if it is less than, interior angles are less than 180, then it will meet at any point. That is the statement of this postulate. So that's all.